Hi everyone, welcome back to my channel. As you know, this is Gajendra Kane from Sri Venkateswara College of Engineering in the branch of Electronics Communication Engineering, second sem. I come back with a new interesting topic that is thermal transducer in the subject Basic Electronics. Let's see the contents on this topic. What is thermal transducer? Types of thermal transducer, resistive transducer, advantages and disadvantages of resistive transducer, and types of thermistor and applications of thermistor. Let's see one by one. What is thermal transducer? Thermal transducer is a device or sensing that used to measure and convert temperature into an electrical signal or output. Let's see the second step, types of thermal transducer. There are two types of thermal transducer that are resistive transducer and thermistor. Let's see the first one, resistive transducer. What is resistive transducer? A resistive transducer is a type of sensor or device that convert in a physical quantity such as pressure, temperature or force into an electrical resistance change. Those resistors rely on the principles that can electrical resistance of certain materials changes when subjected into mechanical strength or changes in the physical parameter. Construction on resistive transducer. Let's see on the screen on diagram of construction. Resistive transducer have a sensing element made up of metal, typically platinum. The construction is typically such that wire is wound on a form. In a coil, achieve small size and improve the thermal conductivity to decrease the response of time 1 to 7 seconds. In many cases, the coil is protected from the environment by a shield or protective tube may be glass or stainless steel or inevitably increases response time but may be necessary in positive environmental. Resistive transducers are either in a metal form disposed on a metal composter and material, and the material resistance is a pure metals of positive increasing similarity with temperature. Resistive transducer is usually connected into a Weldstone bridge. As shown in the figure, it is Weldstone bridge connection. Connection is very small changes in the resistance of sensing element and the meter M used to measure the bridge unbalanced voltage can be calibration in to identify. Advantages of resistive transducer: most stable over the time, most accurate, most repetitive temperature measurement, every resistant to contamination, corrosion PF of the resistive transducer element. Let's say that disadvantages of resistive transducer: high cost, lowest response time, low sensitivity to small temperature change, sensitive to vibration, somewhat fragile. What is thermistor? A thermistor is an electronic component that changes its electrical resistance which changes in temperature. It is a type of resistor whose resistance decreases as its temperature increases. A negative temperature coefficient or resistive thermistor are increased as a temperature increases positive temperature coefficients of PTC. Let's see the two types of thermistor that are positive temperature coefficient thermistor PTC and second one negative temperature coefficient thermistor NTC. Let's see the first one positive temperature coefficient thermistor. Positive temperature coefficient thermistor is a type of thermistor whose resistance is directly proportional to the surrounding temperature. Its resistance increases with an increase in the temperature and decreases with a within the decrease of temperature. Second one, negative temperature coefficient thermistor NTC. NTC or negative temperature coefficient thermistor as a negative coefficient K. Therefore, its resistance varies inversely with the temperature. The resistance decreases with an increase in the temperature and vice versa. The most used type of thermistor is NTC. NTC thermistor are made up of oxides of nickel, cobalt, copper, iron, titanium. They usually operate at a very large range of temperature with a very precise temperature monitoring. Let's see the advantages and disadvantages of thermistor. Advantages of thermistor: less expensive, more sensitive than other sensors, fast response, and small in size. Let's see the disadvantages of limited temperature range. Resistance to temperature ratio correction is non-linear. An inaccurate measurement may be obtained due to the self-eating effect. Let's see the applications of thermistor. Negative temperature coefficient thermistor applications. Digital thermostats, battery pack temperature monitors in rush current limited device, positive temperature coefficient thermistor application over the current protection. Let's see. Finally, conclusion. In conclusion, thermal transducers play a vital role in various applications by converting temperature variations into electrical signals. Like they are essential components in temperature measurement, monitoring, and control systems across industries such as automotive, aerospace, and electronics. The choice of thermal transducer depend on the factor like accuracy, sensitivity, and responsive time. Thank you.